Just wanted to let you know that you are amazing, special, and capable of anything. Thank you for watching this video and taking a positive step for your learning. So the aim of today's lesson is to understand the terminology of probability, so important words relating to probability, and how to calculate probability. Now, in the world of maths, when we're talking about events or something happening, we refer to them as experiments. Throwing a dice is an experiment. Picking a card is an experiment. Any sort of activity where there can be random choices is what we call an experiment in the world of probability. And in these experiments, there are lots of outcomes. An outcome is a possible result of an experiment. Let me write that down. So say if we were throwing a dice, all the possible outcomes would be 1, 2, 3, 4, 5, 6. In other words, an outcome is kind of like listing the sample space, all the different outcomes of an experiment. The event, however, which is the main focus of probability, how likely an event is going to occur, is the one outcome we really want. So maybe when you're rolling a dice, you really want the number 3 because it's my lucky number. No, just kidding. But maybe you just really want the number 3. So your event that you want is rolling a 3. So to make it very clear, an outcome, that's all the possible results of an experiment. So if it says, what outcomes are available, you list all the different results of an experiment, otherwise known as the sample space. But the event, what we're really looking at in probability, the likelihood of an event, is the one outcome we really want. So to calculate the probability of an event happening, this PR is just the word, the PR, the letters, is just the word probability. But remember, mathematicians don't write too much, so we shorten everything. So to calculate the probability of an event happening, we have to write about how often the event occurs that we want. Event occurs divided by all the possible outcomes of an experiment. So I'll show you some examples of how we can do this next. All right, so we are talking about a 6-sided dice. So the first thing we need is the sample space. So what are all the outcomes available when we roll a dice? Well, you're going to get a 1, a 2, a 3, a 4, a 5, or a 6. The next question here says, what is the probability of getting a 3? Now remember, this is our probability calculation. How many times an event occurs goes at the top. So how many times does a 3 appear? Once. Over all the outcomes. How many outcomes are there altogether? 1, 2, 3, 4, 5, 6. 1/6. Done. The next says, what is the probability of getting an even number? So 2, 4, 6. There are 3 times our event occurs, but there are 6 outcomes altogether. So this can simplify your fractions to 1/2 or 0.5 if they ask for a decimal. Last question here says, what is the probability of getting a number less than 3? So there's only 2 here that are less than 3. Still, there are 6 outcomes. Simplify that to 1/3. So this is how we calculate something called theoretical probability. Why do we call it theoretical? Can you see a word? Probability. There, I corrected my spelling. Woohoo! Can you see a word in theoretical probability that might give you a clue what this is talking about? Hopefully you spotted theory. Theory is something that you haven't seen put into practice, but you think it is going to happen. So using the information you got, this is what we think is going to happen. But next we're going to look at another area of probability, which is to do with experimenting. So what actually happens? So sometimes we might be talking about an event, but we've actually done the data collecting ourselves, and we can see what actually happens. So we can say, oh yeah, 50-50 chance of getting odd and even on a dice. But does that actually happen in real life? FYI, it does. But let's pretend we were rolling maybe a loaded dice. So these are dice that are slightly weighed on to certain numbers. So that means you're always guaranteed to get certain numbers. It might come in really handy for Monopoly. So let's pretend we were rolling a dice. We got 1, 1, 6, 6, 6, 6, 3, 2, 1, 4, 6, 6. So if we were talking theoretically, what numbers are on a dice? We have 1, 2, 3, 4, 5, 6. So theoretically, the probability of getting a 6 is 1, because only once that event occurs out of 6 outcomes. But here, what is our experimental probability of getting a 6? So after throwing a dice a couple of times, 1, 2, 3, 4, 5, 6. 6 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Ooh, that comes to a half. Does that match up with our 1/6? So this is proving how maybe when you do the actual experiment, your data might come out a little bit different. So let's have a look at another one here. We have done an experiment of spinning this spinner. Whoa, so cool. So there's only 4 numbers, so technically, theoretically, the probability of getting any number is a quarter, right? Let's see what actually happened here. So let's look at the probability of getting a 3, the experimental probability of getting a 3. Well, that would be 1, 2, 3, 4. 4 out of how many times did we spin this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. Oh, that's actually a bit different. That's 2/5. We thought it was going to be a quarter. So experimentally, it was different to our theoretical probability. How about the probability of getting an even number? Easy, that should be 50-50, right? These are the 2 even and that's 2 odd. Let's see. So 1, maybe I'll use a different color so you guys can see. 1, 2, 3. Oh, hold up. 3 out of 10, that's nowhere near 50. Well, it's kind of near, but it's not that close to 50-50. So how interesting that in reality, we got a different probability compared to theoretical, what we were thinking. The last one's a bit of a challenge that we're going to think about today. And it says, based on this experiment, so we've done some experiment, we've done some spinning, how likely would we get a 3 if we spun the spinner 1,000 times? So, well, in 10 times, we spun it 4. We got 4 times we got the number 3. Maybe I'll say 4 spins. If I say 10 times, I'm going to take 10 spins. We got 4 times. But now we want 1,000 spins. Well, that's just 100 more, isn't it? So maybe we should times this 100 more. That means we would get it 4 times. 400 times. Oh my gosh, not 4 times. So this is showing how we can use the experimental probability to find out what might happen if we were to do an experiment multiple times. So the main thing to understand by now is that there's 2 different types of probabilities we can calculate. The theoretical probability, so in theory what we think might happen, versus the experimental probability, which is based on experimenting. So hopefully that makes a little bit more sense, and drop some questions in the chat if you're not sure of anything.